All right, section 12.8, linear programming. All right, so what we're going to do is, first example, only example actually, is we're going to have this objective function. And you're going to be given this objective function. I'm using I right here. They may have Z equals something. They may pick different letters here. But basically, all it means is this is the testing equation, okay? So this is going to be our objective function, or objective equation, I guess would be the more precise way to talk about that. And if you're dealing with like a word problem situation, that might be a profit equation that you could charge, or a revenue equation where like you sell two different products. You've got a product A that you sell for 12 for a penny or 2 pennies, and then product B that you sell for 3 pennies. And then you put that together, and that's how much revenue you have out of that. Or hopefully those are in thousands or something like that for selling it and make some real money out of that. But either way, it's some sort of equation. You're going to be given that equation on quiz and test for that matter, as far as my class is concerned. Okay. Then you will be given what are called constraints. Constraints are things that close in. So, like, if you're constrained, that means you're tied down. The walls are closed in. You're in a small area. So when we're talking about constraints with equations and graphs, we're talking about inequalities. So we might have this constraint: x is greater than or equal to 0. Another one that's y is greater than or equal to 0. X plus y is less than or equal to 25. And then we might have x is greater than or equal to 15, and y is less than or equal to 5. All of those are constraints for this particular problem that we're identifying here. So with the constraints, what you want to do is graph those on a coordinate plane. Okay. So let's see. A lot of multiples of 5 there. So I think I'm going to change my scale to where I'm going by 5s instead of by 1, so I don't have to draw it so big. So I'm going to draw myself a coordinate plane. Looks like everything's happening in the first quadrant, so I don't need a whole lot of room in any of the other quadrants. So that's my graph's going to be mainly first quadrant stuff. Okay. This first one, x is greater than or equal to 0. That's a vertical line, remember? And shading would go what direction for that one? Greater than would go to the left or to the right? To the right. Okay, I'm not going to shade it. I'm just going to put arrows on it. Tell me there, because I've got so many. If I shade it I can't do it light. It's either on or off with this thing. So I'm just going to put arrows saying that we would shade that way. Okay, and then we got y is greater than or equal to 0. So if I graph that one, that's basically just the x-axis. And greater than or equal to 0 would go up. So the shading, if it were just those two constraints, it would be overlapping in this area, right? But we got all these others to deal with here too. So this is where the scale comes in. X plus y is less than or equal to 25. If I think about graphing that, what do I need to do? Get x over there, so it'd be y is less than or equal to negative x plus 25. And then I could, use my graphing skills there, 5, 10, 15, 20, 25. So this is, y-axis going by 5s. X-axis, I'm going to go by 5s there too. So down 5 over 5 would be a -1 slope. It's going to cross the x-axis there. It'll be a solid line because it's equal to. Shading for that one. I'm going to check 0, 0 because the line doesn't go through it. 0 plus 0 less than 25. Yeah, so that means I would shade towards 0, 0, so that direction. So if it were just those three, it'd be this triangle here would be my constraint, my solution area out of that, okay? But we got two more. Here we got x is greater than or equal to 15. So I'm going to go to 15 on the x-axis and put a vertical line. So if I'm going by fives, it'll be the third block. Vertical line. And it's greater than or equal to. So that means I would shade right or left. Right. So greater than. So if it were just the first four constraints, it would be this even smaller triangle right here. That's the solution area. We got one more though. Y is less than or equal to 5. So we go to 5, which is the first line. I'll put it in orange because they wanted it against Kentucky, but it still counts. So. And then less than would be shading down. So the solution area that we're actually looking at is this area, this little trapezoid looking shape right here. So because our scale was larger, it makes that look like a real small area. But now here's what we've got to find is the important points, okay? The important points are the corners of that polygon. Okay, so the corners of that polygon. So some of them are easy to find without using system of equations. Some you might need to use a system of equations for. So if I look at this corner here, that's the point 5, 0. So that's a corner. So corners 5, 0. And then we have right above that, right there where the orange and green line intersect, that'd be the point 5, 5, or excuse me, 15. That's 15, 0, not 5, 0. 15, 0. And then that would be 15, 5. Would be the corner where the orange, my orange line and my green line intersect right here at this top left corner of that. Best way to describe that. Then this one down here is pretty easy to find because it's 25, 0. And then that one right there kind of hanging out in the middle of the world there is the one that's a little bit more difficult to find. But it's the intersection of what two lines? Or which two inequalities? Yeah, this one and this one. So what you want to do is solve that like a system of equations to find where they intersect at. Okay. Well, this tells us that y equals 5 right there, right? So I could use that to find x. But if y is 5, then x would be 20. So the point would be 20, 20, 5. Those are corners of our polygon. That's the important points. Okay. Next thing to do is to maximize or minimize using those corners. Copy. Maximize. We're going to do both on this problem. And minimize. The objective equation. I'll abbreviate that. Okay. What that means is plug those in as x and y into the objective equation and get what the result is. Okay. So we're going to plug in those points. 15, 0. So that'd be my objective equation is I equals 0.02x plus 0.03y. I'm plugging these things in. So I equals 0.02 times 15 plus 0.03 times 0. And I'm getting the result for that. which would be 0.2 times 15 be 0.3. And then I plug in 15.5. That's 0.3 plus 0.15 be 0.45. Then I'd plug in 25 0. Be 0.5. And then I would plug in 25. Work that out. So that'd be 0.4 plus 0.15. Okay. Now, if you're going to maximize that, what are you looking for? The most. Okay. Which one would be the maximum? Yeah. So this whole piece here is our maximum. Where would our minimum be? Yeah, at 0.3. So it would be that whole piece there. The ordered pair is the location. The actual number is that the maximum or minimum value. Okay, so if it asks for a maximum or minimum value, it just says find the maximum or minimum, we're talking about these numbers. Okay, if it asks for where is the maximum or minimum, we're talking about the location, the ordered pair as a location out of that. Not going to get too difficult with this. You know, it's going to be straightforward. If you look at page 927, numbers 3 through 8, they've already got a graph drawn for you and actually got the points labeled for you. They just 3 through 8 just changes the objective equation, and it asks you to do exactly what we did there: maximize or maximum or minimum for that. Okay, so that's 3 through 8. Now, one more like what we just did would be 9 through 17, where they actually give you the objective function. They say z equals is what they're using, and then they give you the constraints. It says subject to, and that means these are the constraints after that, and you would need to graph that. You can graph it with a calculator if you want to, and then just think about shading on the graphic calculator if you want to do it that way, or do it by hand. Doesn't matter to me which way you do that. But you got to get those ordered pairs where the corners of that polygon are. That's the important things that you've got to find. And you find those and either maximize or minimize it according to what they ask you to do. And you're just plugging in those corners, those ordered pairs, into the objective equation. Work it out. Maximum is the biggest one. Minimum is the smallest one. It really doesn't get much more difficult than that. I'm not going to. I was harder on you guys on the nonlinear systems. It'll be easier on you on this part then, and kind of balance it back out. Okay. So that's our last lesson of the semester. The end.